Okay, so we were doing this last time. A number of times you show an item and the type of item, words, pictures. I showed you how you can organize the data and convert it to a table. Those are the responses to get the two-way ANOVA. We went over to star, down to ANOVA, two-way. Responses are the responses column. Row factor was the number of times. Column factor, the type. Is it a word? Is it a picture? What was the conclusion last time?
There was no evidence.
No. Stephanie, right? What's your name? Stephanie?
Yeah.
Yeah.
There was no evidence.
No evidence to do.
That's all I have written down.
There is no evidence, but to what? So the objective of a two-way ANOVA is to determine an effect. What are all the effects that we have? Main effect, interaction effect, two main effects, one interaction effect. And did we find that there is an effect due to the number of times that someone sees something and have good recollection of that? No. Did the type of item that was shown, did it have an effect in terms of recollection? No. Did they interact in some way? No. And how did we get to that conclusion? I'm going to select interactions, means, we used it ANOVA, and the row factor is times, column factor, type, interaction would be type and time combined. Error is simply within. Good. So the p-value for each case is 0.055, 0.3089, and 3089. That is our means table. Now, there was something interesting that happened with the means table. When we totaled those two, we got 86.5, but we had to divide by the number of means to get that 43.25. So this has a name. What is that name? Ground mean. So if we had 3 rows, we will sum all those 3 rows, divide by 3. Yes. So ground mean is what we will be using. Okay, do we have the table written down? Another table, means table. So these means were obtained from averaging the 2 observations in each cell. And that plot right there is what we call an interaction plot. An interaction plot is used to see if there is interaction or not between the 2 variables. I kept going like this constantly. Did you observe? Yes? That's what I expect to see there. And next. So if the red and blue lines were going this way, it indicates, they indicate that they interact. But if they are parallel to each other, either in a decreasing way, increasing way, no interaction. Good. I would consider these to be not parallel because parallel lines don't intersect, but they're going this way. They don't fall across an X. So no interaction, agreed. I'm not going to ask you to create a plot, but interpretation is key. Same, pictures, words, no interaction. So they're not parallel, but they don't make a cross. If they make an X, then there is interaction between the two. So the pictures agree with whatever the table is telling us. The table said no interaction. Good. Okay. That is using StatCrunch. We are going to reconstruct that table using the calculator. So things that are needed would be the means and those two column means, row means, the ground mean, and the original data, which is not showing up here, but if we go back to our data. Again. I guess. So that is our data. So row one, ones and words, we have 44, 46 as the observations, ones, pictures, 67, 69, two observations. Row two, the word column at two observations, 48, 12. Row two, pictures column at 38 and 32. So the order matters in one case. So I'll go ahead and write this. So 44, 46, row one, column one. Row one, column two, we have 67, 69. Row two, column one, 48, 12. Row two, column two, 38 and 22. Good. Now, let's go back to the means table. We know how to find the means. Easy to find. When you do homework problem or a problem on the exam, I'm not going to put 15 observations in there. That's it. It's either going to be 2 or 3. That's it, depending on the table structure. So that is our two-way ANOVA. Let's go to the row means table. Start that and select. You've got to select these, or else it's not going to show. ANOVA means table, 68 plus 30 divided by 2, 49, 37.5. Order doesn't matter. So if I average those two, 49 and 37.5, what will I get?
86.5.
If I average.
Oh.
Not sum.
The 43.
The 43.25. So we can use multiple lists in the calculator, but let's just keep it simple. I'm going to enter the averages, 49, 37.5. We entered those two values into press start over to calc. One more starts. The row means are in list 1. Ready? Enter. I'm getting a whole bunch of numbers. I'm getting SX. I'm getting 3,807.25. The value that we have for column is 264.5. So we are trying to get to that value. If you do it this way, for this particular case, you're not going to get that number. So the key part here is to take each value, and you enter 249, like 49 minus 43.25. That is 7.5 minus 43.25. Good. Press start over to one last part. Second one. And enter. Good. Yes.
So it's 49 minus the 37.5, and what is the second one?
37, so 49 minus 43.25. 37.5 minus 43.25. So you take each column mean and subtract. Good. Riley?
Why did you do the first variance with without subtracting?
The first one I showed because we're going to use just finding the variance in another case, and I don't want you to get them. Okay, now I want you to look at that second number, or third number, sum sideways m s squared. Easier way to remember sum of squares. I have 66.125. Yes? You have to multiply that number by the number of observations per column. They are the same. They have to be the same in this type of ANOVA. So 1, 2, 3, 4, 1, 2, 3, 4. So pick up your calculator. Did we write this number? 66.125. Multiply that by 2. What do we get?
264.5.
264.5. Does that match up here?
Yes.
Good. Now we want to do the same with the row variable. I'll keep that value over to the second list. You have 6 lists in this calculator, that's plenty. This time, I'm going to enter each of the row names that I have displayed. 56.5. Later, we are going to find variances directly. I don't want you to do it for these two. Minus grand mean 43.25. Thursday minus 43.25. Each value minus the grand mean. Do not subtract by 86.5. Back to start. This time the data is in list 2. I would rather keep them because in case you made a mistake or if you want to verify, you can go back and check. So list 2, I'm getting 351.125. Yes?
Yes.
Over here we have 1445. Previously, whatever number we had, we multiplied by the number of observations per column. They have to match up. That's the only case we are going to do in this class. This time, since we are looking at row means, you have to multiply 351.125 by the number of observations per row. In this case, still 4. Good. So take 351.125, multiply by 4, and tell me what you get. 1,404.5. Good. Okay, we took care of 2 of them. Onward. We know how to find variances. Yes, variance of the data set. Are we done by team? Okay. Back to our table. Number 1 of 2, list 3. I want you to enter every single observation that we have in the tables. Use one variable statistics and tell me what the variance is. So we have in total 2, 4, 6, 8 observations. Put all the 8 observations in list 3 and tell me what the variance is. So I entered all observations in the calculator, list 3. I'm going to press start over to count number 1, list 3. I have 19.6886, but that is not the variance. It is simply SX. What do we need? We need to square it in order to get the variance. The square of that is 93.688 square, 300.
387.64. 387.64.
Okay, 387.64. Don't forget to square. Retain at least 4 decimal places. As I mentioned before, round at the very last step. for the purposes of reference, that number, degrees of freedom, I wrote, maybe the first time we did, I called the number of rows as lowercase r, number of columns as lowercase c. That number right there is r minus 1. Yeah. Number of rows minus 1, 2 minus 1, 1. The second number for the column effect, number of columns minus 1. Yes. We will deal with in fraction later. The total is the total number of observations, r times c, multiplied by n. Instead of putting it in terms of r and c, I would simply recommend that you count the total number of observations in the table. 8, 8 minus 1, 7, and that's what's right here. Why do we need that number? Once you find that variance, 19.886 squared, I get 387.64 squared. Good. And damn it, 387 is after squaring. 19.886 is just another deviation. Square it to get the variance, multiply by that 7. Good. 2713.48. Does it match that value of that?
Yes.
Yes, okay. Just as a reference, I'll write here on the side the DMs, rows, columns, interaction, error, total. I'll call n to be uppercase n to be the number of observations. Just the DFs, r minus 1, c minus 1, n minus 1, total number of observations. We will find these different values. Good so far? Okay. We have to find 2 more sum of squares. We will get to that. So the fourth one, start. What is another word for error? Very good. Within. So that is your hint. Within means within cell. Good. So we have the means for each cell. Agree? For the first one, it is 45. 1. It is putting it in alphabetical order, but our table has things reversed. So first row, first column, we have 44, 46. Average those two, I get 45. Good. So these averages are important. So when you are doing a two-way ANOVA, things that you need to figure out right away, means table, 1, the width of 2. If you write them down separately, then the process will be straightforward. Okay. Put a star, double star, write it in a different color, do something. This is key. within, hint, within cell. So 44 and 46 are in the first cell. Do we agree? One first row, first column. So when you type in list 4, 44 minus the mean for that cell. What is the mean for that cell? 45. Yes? But 45 there. Enter. Don't forget about, don't care about the stuff. Not that big of a deal because we are going to square stuff. 46, still it's in the ones word cell. So 46 minus 45. Good. Next two rows in the calculator, 67 and 69, would correspond to ones and pictures. So 67 minus 68. 69 minus 68. Good so far? Okay. Let's see if you can fill in for the next 4 values. And do one last task on list 4. Let's see what you get. The way to remember this process is row means minus the ground mean, put it in the calculator. That will give you SS, provided you multiply by the number of values per row. Do the same for the column. Number of cells per column needs to be multiplied after you get the values to calculate. Within means you are going to use the observations within the cell and subtract. Right, go ahead.
Oh, so right now we're trying to find the 2 remaining,
Yes, that's all we have.
Is this gonna be posted in your lecture, that way we can review back on it?
I'll try. I am doing it here, so if
Because I
it's
tried looking for the StatCrunch 1-2 last class, but you didn't have it in there.
I haven't gotten there yet, because I have to look through it. So, and then the power went out halfway.
Yeah.
So, we will do another example. Where was that? So we did it for the first row. We want to repeat it for the second. So 48 and 12 belong to one cell. 48 minus the cell's mean 30. 12 minus the cell's mean 30. I have a question. A couple of you asked me, well, does it matter in which order you subtract? Doesn't matter because we are going to square. So no need to worry there. 38 minus 30. 8. 22 minus 30. Negative 8. Start list number 4. Those are the values that I get. Last couple of cases, we picked some of squares, but multiplied those by 4, the number of observations per cell, per row, number of observations per column. But here, you do nothing. Simply grab that up. 780. That is right here. Why am I doing nothing? That 4 is accounted for there. Good. So 780 here, that is 780 there. Good. In terms of degrees of freedom, I've got two missing, right? I wrote it for rows, columns. Last one, you might be wondering what that is. Well, that is simply 1 minus 1 times c minus 1. Multiply together. Good. So that leaves us with one item, which is right here. It is going to be a lengthy formula. Your book, again, is for goals and types that entire formula with a whole bunch of letters. I don't want you to do that. This is easy to remember. Yes, cool. DF, there's easy. The concept is if I add all the DFs, it must equal to the total, correct? That's what we did with ANOVA. Between the F plus within the F sums to the total, DF. Well, if I know this to be 7, the total, that's 1, row 1, column 1, 2 minus 1 times 2 minus 1, 1. If I want to find that missing value, what should I do? Subtract the sum. What is 7 minus 3? 4. Good. Don't use that lengthy formula that's in the textbook. So, Riley points out, isn't there one more? We can find this using the calculator, but the process of finding that, painful. It is a lengthy formula. And even with a calculator, you've got to know a whole bunch of details. But if we use the same logic that we did up there, when we sum all the individual sum of squares in a regular ANOVA, SS between, SS within, add them together, you get the total. Agreed? Yes? Same logic. If I add the SS for rows, columns, interaction, rows, columns, and error, subtracted from 2713.5, you will get the interaction value. So, add 1404.5, 264.5, 780. Take that away from 2713.5. And 1404.5, 264.5, 780. Take that sum away from 2713.5. You should get 264.5. Did we get that number?
So after you get like this 7.3.5, what do you do after that? Yeah, so after you add the working of 4.5, 264.5, 788, etc.
So you take that sum, you are subtracting that away or taking it away from that total.
Is it just a coincidence that it's the same as
It is a coincidence. That's a good question. They're not going to be the same always. When I do my next example, you will see that. Good. So, did we get 264.5? What did we get? The way you subtract, right? You always subtract the smaller number from the bigger number. Even if you get a negative value, make it positive because we are referring to sum of squares. Squares cannot be negative. But by accident, if you get a negative value, get rid of that negative sign. Good so far? So the order is do times type interaction total for the DF, and then that will give you the DF for error. When it comes to SS, you do interaction and last because it's the most difficult one. Good. Once you have these two, everything else is easy. Why? Sum of squares divided by 1 will be that. Yes. 264.5 over 1 will be mean square. 264.5 over 1, that's fine. 780 over 4, 190. Yes. How did we find the F statistic in ANOVA? You can look at your notes. The F ratio,
MS between over MS.
MS between over MS within. Now, we have a whole bunch of terms, 3 different MS values. So we have to do individually. So 1404.5 over 195. Tell me what you get. It better be 7.2025, or else my life will be meaningless. The first MS divided by MS within. Did it match up? Yeah. The second MS divided by MS within or MS error, it should equal to 1.356.
Please repeat that one more time.
So the first MS divided by MS error or MS within, they are the same. You should get 7.202. The next MS divided by MS error, you should get 1.356. Good so far? Okay, that leaves us with one last step, finding p-values. Your calculator will do this for you. Ready? So, in your calculator, press second, arms, button right next to clear, second, arms. If you scroll down, you should see FCDF. You're about to F it all up. No one knows. Okay. Finally, FCDF. We want to enter the F statistic for the first factor, which is row, 4 decimal places, so 7.2025.
Would that be for lower, upper?
That is correct.
Okay.
So if you have a newer version of the calculator, in lower, you would put the test statistic value, 7.2025. The upper is infinity. You can get that by doing second, comma, funky E99, comma. We found MS by dividing each, F ratio by dividing each MS by MS error. So We pick the DF for the first one and DF for error. So 1, 4. Good. 1 comes from row, 4 is coming from error. Close brain. Enter. Does that probability match the p-value of it? Yes. Same process, second, marks. Number 10.
And why do we have to enter in the infinity sign?
Because we are trying to find the area above. So we start at the test statistic, keep on going. Now, previous articles, your professor might have suggested pick a big number. You can't do that, but that is not the safest bet. So I always recommend that you pick infinity. You can get infinity by doing E99.
Where did you get the 1 and 4?
So 1 here, 4 there. So finally question.
So, and you're using the degrees of freedom for each row, right? Like on this will be 1 and 4 every time, but it could be different.
It could be different. So the next F statistic is 1.35. That's for the Cullen factor. So 1.356, comma, second comma, E99, the upper value, infinity. DF for the Cullen factor is 1. DF for error is 4. You get 0.3089. Good. The last case, same process. In this problem, we get the same value, but the process is to take 1.356 as lower, upper infinity, DF for interaction, comma, DF for error. Good. Are we clear? Okay. I'm going to summarize. We talked about that. So this is the process. If you want to do it using the calculator, I strongly recommend that. Step 1, write down the DFs, most important part. Good. So this is easy. Row factor DF, column factor DF, interaction DF. They have formulas. Last formula. Once you find those 3, you subtract it from the total. You will get that number. Good. So this is simply n minus 1 minus sum of other DF values. Good. Step 1. Step 2. Find the mean table. Find the grant mean. Do not forget that. So mean table. So row SS, column SS. You are using the calculator. But don't forget to multiply by number of rows, number of columns for the appropriate case. Otherwise, you're only getting part of the answer. Remember, earlier it was 66 point something. I multiplied by the number of observations per row. They will be the same. When you do that, you got 264. Same with the other case. If I didn't multiply, I got 351.25. Once I multiplied, I got 1404. Next step, find total SS. This is easy. You find standard deviation for all observations. Square that. Multiply by total DF. Good. Which is simply n minus 1. Good so far? Okay. Which one should you do next? Interaction or error? Error. Interaction is the last thing that you should do because it's difficult. Hint within. So each cell observation minus the mean of that cell, not the ground mean, the cell mean. Then you do one last pass for that list, and you will find error SS in sideways X1. Good. If I have row SS, column SS, total SS, error SS, all I have to do is subtract those SSR, SSC, SST, SSE, SSI. Interaction is simply total value minus row SS minus column SS minus error SS. You are good. Once you have the correct SS values, correct DF values, like easy from there on. It's just division and multiplication and FCDF. So very last step, step 4, you get p-values using FCDF in your calculator. The book uses comparison distribution cutoffs. That is easy to find. We've done it with ANOVA. They will provide you the table. All you have to do is compare your sample score, which is the F ratio, with the cutoff. That part is straightforward. Do we follow this? So, Barnum, did you have a question? Anxiety level, or anxiety is the road factor, low, medium, high. Social skill rating, below 5, greater than or equal to 5. Good. The scale is from 0 all the way up to 10. 0 wouldn't make sense. Let's do 1 to 10. extrovert, 1 introvert. Good. Okay, these are the numbers. Change that to a 3. I want to keep it simple. Every cell has the same number of observations. Agreed. Every row has the same number of observations. Agreed. Every column has the same number of observations. Agreed. So try to do the process that we did today for this example. I will start here, do a couple more things, and we will be done.